Problem 209, Classical Mechanics. The question is, after a perfectly elastic collision of two identical balls, one of which was initially at rest, the velocities of both the balls are non-zero. The angle theta between the final velocities in the lab frame is. In the present problem, an elastic collision is described. We have to find out the angle between the final velocities. This is the mass m, first mass. This is the second mass, which is at rest. The second mass is at rest. This ball having mass m is colliding with the second ball with the velocity u. And after collision, one ball will move in one direction with velocity v1. The other ball moves in another direction with velocity v2. Here, theta 1 plus theta 2 is the angle between the final velocities. Now let us write the conservation of linear momentum along the x-axis, that is mu, that is equal to mv1 cos theta plus mv2 cos theta 2. This implies u is equal to v1 cos theta 1 plus v2 cos theta 2. Let it be our equation number 1. Similarly, we have the conservation of linear momentum along the y-axis. We can write m into 0, that is equal to mv1 sin theta 1 minus mv2 sin theta 2. This implies that 0 is equal to v1 sin theta 1 minus v2 sin theta 2. Let it be our equation number 2. Since the collision is elastic, the kinetic energy before collision and after collision are equal. Therefore, we can write half m u1 square, half m u square is equal to half m v1 square plus half m v2 square. This implies that u square is equal to v1 square plus v2 square. Let it be the equation number 3. From 1 we can write, let us square the equation 1, that is u square is equal to v1 square cos square theta 1 plus v2 square cos square theta 2 plus 2v1 v2 cos theta 1 cos theta 2. Let it be equation number 4. In the same way, we can write from equation 2, we can write 0 square is equal to v1 square sin square theta 1 plus v2 square sin square theta 2 minus 2v1 v2 sin theta 1 sin theta 2. Let it be equation 5. Now let us add equation 4 and 5. This implies u square is equal to v1 square. Now cos square theta 1 plus sin square theta 1 is 1. Similarly, we have cos square theta 2 plus sin square theta 2 is also 1. Hence, u square is equal to v1 square plus v2 square plus 2v1 v2 cos theta 1 cos theta 2 minus sin theta 1 sin theta 2. This implies u square is equal to v1 square plus v2 square plus 2v1 v2 cos theta 1 plus theta 2. Now theta 1 plus theta 2 is theta, which is the angle between the final velocities. Therefore, u square is equal to v1 square plus v2 square plus 2v1 v2 cos theta. Let it be equation number 6. Now from equation 3, we have u square is equal to v1 square plus v2 square. Therefore, substitute v1 square plus v2 square in the place of u square. We have v1 square plus v2 square is equal to v1 square plus v2 square plus 2v1 v2 cos theta. Now comparing LHS and RHS, we can conclude that this term 2v1 v2 cos theta should be 0. That is only possible if cos theta is equal to 0 or theta is equal to pi by 2. Hence, from the given option, option A is the right option.